Hello everyone. This video is going to cover the lecture notes for week 14, and the topics cover is just exponential functions. So what is an exponential function? An exponential function is a function that has the following form, where a is called the base and a is a positive value, and a is not equals to 1, because if you have 1, the answer will always be 1. For example, 1 squared is 1. 1 to the 100 power is 1. So therefore, a cannot be 1. And the domain is from minus infinity to infinity, pretty much all the real numbers. Now, exponential functions, like you've seen it everywhere, especially now with the pandemic. Exponential means that either increases very fast or decreases pretty fast. So now, these are the two most basic bases, 2 and 3. And all you have to do to complete this table is plug in these values in the exponent. Now, anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8, and so forth. This one is 2 to the negative 1, which is 1 over 2. This is 2 to the negative 2, which is 1/4, and so forth. 2 to the negative 4 is 1 over 2 to the 4, which is 1 over 16. Okay. Same thing for 3. 3 to the 0 power is 1. Remember, anything to the 0 power is equals to 1. This will be 3. This will be 9, 27. And then it will be 1/3, 19, 127, and 181. So notice the pattern. If the exponent is positive, you get this. Negative, you get 1 over that. Now, there is a special base that is so special that it is technically the most important base in math, and that's the letter E, which is around 2.71828. So this is an irrational number. So this is the most famous base, and we're going to look into this one a little bit, but this is very popular in math. Actually, everything in math can be based on this letter, believe it or not. Now, if you look to the graphs to the right, which are these ones right here, notice how, like we say, the domain clearly is from minus infinity to infinity. So all of these, you have arrows that they keep going. So you can see that the domain is from minus infinity to infinity, and the range is from 0 to infinity, not including 0. Okay, 0 is not part of the range. So therefore, if you look to e to the x, which is the line in red here, notice that all of them go to 1, because anything to the 0 power is 1. You can see that y goes to infinity as x goes to infinity, and y goes to 0 as x goes to minus infinity, which will be this case. Okay. Now, what about if the exponent is negative? This is actually related to also something we did before with reflections. If the exponent is positive, the graph will go up like this, and then if you reflect it on the y-axis, then this part will increase, but this one will decrease. So this means that the graph of g equals to minus 2x looks like the graph of f of equals to 2 to the x, except that this will be reflected on the y-axis. Okay, and we talked about this before. Remember that f of minus x is going to be 2 to the minus x, and if you change x by minus x, that means reflect on the y-axis. So therefore, the graph will look the same as 2 to the x, except that now it's going to be reflected on the y-axis, so it's going to look like this. So this is going to be y equals to 2 to the minus x, which is actually the same thing as 1/2 to the x. You should check that. And let's say that we call it g of x. Notice that now g of x goes to 0 as x goes to infinity, and g of x goes to infinity when x goes to minus infinity. So 0, and now it'll go to infinity. Then it's asking you to write this without a negative exponent. Well, remember that 2 to the minus x is the same thing as 1 over 2 to the x. And since 1 to any power is equals to 1, this is the same thing as just this. Now for this problem, you just need to plug it into the calculator. Usually the button for the calculator is this, or y to the x. That's what you do in the calculator. So therefore, g to the 4 will be 2 to the 4 minus 1.75. This is the same thing as 2 to the 2 to 5, and this is 4.75. You should definitely check this. h2 is going to be 3 to the 2 times 2, so this is 3 to the 4, which is just 81. And k to the 1/3, this will be e to the 1 over 3, which is around 140. You should check that. Right, the next thing we're going to do is graphs of exponential functions, but we're going to use the information we did before when you translate the graphs, moving it to the right, to the left, or up. We already did the rotation on the x-axis or reflection on the y-axis. So if you look to this graph, this is exactly the same thing as 2 to the x, except that is moving 5 units up. So therefore, 2 to the x, remember this is 1, 2 to the 1 is 2, 2 squared is 4. So therefore, this is the graph of 2 to the x. Okay, so this is y equals to 2 to the x. So if you want to move 5 units up, then you go 1, 2, 3, 4, 5. So it will be here, and then 1, 2, 3, 4, 5. So just move everything 5 units up, and this will be the new graph. This is not new. We did this before. So this will be g of x, and it will be f of x. Now this one is okay. So this one was move graph 5 units up, and this one is going to be move graph 4 units to the left. The same thing we did before. So here again we have the graph 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, and so forth. So this is the graph. So this is f of x. And then g of x, you're going to move it 4 to the left. So therefore this will be 1, 2, 3, 4. Then 1, 2, 3, 4. 1, 2, 3, 4. So the graph is now going to look like this. Okay, so notice that doing these translations can change the domain and the range. So the domain of g is still going to be from minus infinity to infinity, but the range, since you move it 5 units up, now it's going to go from 5 to infinity, and the horizontal asymptote is going to be y equals to 5, which will be this line right here. Now in this case, the domain is still the same, and the range is still the same. Nothing happens. And exponential functions, if you don't do any translation, or you just move it left or right, they always have a horizontal asymptote y equals to 0. Notice that this line is not crossed, so this is the horizontal asymptote. Now, Exponential functions have a particular thing that other functions don't have. The main property is this: that shifting an exponential function is related to just stretching an exponential function. For example, if you multiply this just by the base, which is 2, then what happens is you get the following function. So kx, it will be 2 to the 1 times 2 to the x, and by the properties of exponents, this will be 2 to the x plus 1. Remember that this means moving the graph of 2 to the x 1 unit to the left. Okay, so it doesn't stretch the graph, it's just shifting it to the left or to the right. So rewrite a single exponential term. Well, this will be 2 to the x plus 1, which is what I just did there. And describe a new way is instead of stretching, you're just shifting to the left. I already explained that here. So the conclusion is that for exponential functions, shifting is the same as stretching, which is not the case for other functions. All right, so finally, let's see some applications of this. This function right here is called the logistic equation. Notice that here we have e. The value I told you is very important in mathematics. Remember that e is around 2.71 and it keeps going just like pi. So here this equation represents the number of infections, just like COVID-19 right now, at time t. Okay. So the problem says the following: an infectious disease begins to spread in a small city, a population that has 10,000. The number 10,000, there's no accident that 10,000 is here because you cannot have more than 10,000 people. After 3 days, the number of people that have succumbed to the virus is modeled by this function. So the first question is, how many people are infected initially? So initially just means that t is equals to 0. Okay, remember t is equals to 0. That's what it means by initially. So therefore this will be equals to 10,000 divided by 5 plus 1245 e to the 0. Remember that anything to the 0 power is 1. So therefore this is the same thing as 10,000 divided by 5 plus 1245, which is 1250. And this is equals to a. So initially there is only 8 people infected. Part B says how many people will be infected after 2 weeks. Well, 2 weeks in terms of days is equals to 14 days. Because remember here t is given in days. So therefore you need to find how much is b of 14. And this will be 10,000 divided by 5 plus 1245 e to the minus 0.97 times 14. Here you have to be careful with the calculator. This is 10,000 divided by 5 plus 1245 e to the minus 13.58. And this is around 1999. Same thing for 3 weeks. For 3 weeks, you had to find b of 21. Now, part C is asking for the end behavior. And the end behavior is what happens to this as t goes to infinity. Notice that here we have, notice that we have e to the minus 0.97t. So the 97 is not important. What is important is that it's negative. So if the graph is negative, remember the graph looks like this by reflecting on the y-axis. So as x goes to infinity, this goes to 0. So therefore, as t goes to infinity, b of infinity, technically, it's going to be 10,000 divided by 5 plus 1245 times 0, because this is approaching 0. So therefore, this is 10,000 divided by 5, which is 2,000. So this will be the maximum number that will be infected, which you can see that from the graph. So notice how this increases pretty fast as the exponential part, and after 10 days, usually it goes to 2,000 for this particular problem, and that's it. Now the last question is, how long is it going to take for 1,000 people to be infected? So 1,000 is going to be equals to 10,000 divided by 5 plus 1245 e to the minus 0.97t. Now to solve this problem, it requires logarithms, which we haven't done, but we will do that in the next week's lecture notes. So for now, you can really solve this problem, but you can look to the graph and approximate it from the graph. From the graph, it says around 10,000. I mean 1,000. 1,000 is right here, which you can see this is around 6 days. But in the next week, or in next week lecture notes, you'll find a precise way to find this. But now, by just looking to the graph, you can see that it's around 6 days. And that's it, people.